Cool. So yeah, we have this set up at a very basic level. We've got like, start and end of the game, but at the minute we're missing something quite big. Like we don't have a way to actually play the game or to take shots. So I'm going to create a script. One thing I'm going to say is like, if you need to use this script like whole class and like implement it in your game, that's totally fine. This module isn't game programming. What I'm trying to do is show you ways to do things, but like if you make games by like cobbling together lots of different stuff that you find, that's totally okay as long as you're able to understand how they work. And I hope that I'm able to give you enough of an understanding to be able to piece these together. So the first thing I'm going to do is create a folder called scripts, and I'm going to put my 2 existing scripts inside there. And I might get an error while this moves, and yeah, then that fixes it. One thing I'm going to do is, it'll be the same thing. It's your IDE. If you move scripts afterwards, it might have an issue. Okay. 2 scripts so far. So what I'm going to do is select the ball, and I'm going to add a script to the ball, and I'm going to call this ball. And I'm going to hit create now. Like that. Sometimes it'll open with JetBrains, sometimes it won't, but it is here. I think I can move that inside in JetBrains and yeah. So you can move this in your IDE as well. So here's the ball movement script. So the first thing I'm going to do is try and get a few different things set up on this. So we're going to create some variables that we're going to use as we make this. So I'm going to start off with the public variables so that they're at the top. So I'm going to create a public float, and one's called shot power. One's called max force, and one's called min. I'm going to call this one sleep speed. This is going to be what we're going to use this for. The shot power is like how much we are hitting the ball by. The max force is like depending. We're going to click on the ball and we'll drag the cursor back to give it force. But one thing we probably want to be careful of is like if we drag the ball back like half the screen, we might give it too much force. So we're going to set just a maximum basically on that. And then lastly, the sleep speed is just at what stage our rigid body is going to start moving and start going to sleep, basically. Now, we will create a few more here, but for now we're just going to focus on the gameplay. There's going to be a UI element on this ball to show how we're kind of dragging it. So I'm going to create a few private variables, and the first is going to be rigid body. I'm going to call this my RB, and that's just going to be a reference to the rigid body that's on the ball. I'm going to create a private float, and that's going to be called shot force, and that's just going to be a combination of shot power and the direction I'm shooting in, basically. Then I'm going to create some private vector trees, and these are going to represent the start position of the mouse, the end position of the mouse, and the direction that the clicking on the mouse to the ball gives us. And I'm going to create a couple of booleans, and these are going to be private as well. And one is going to be called can shoot, and the other is going to be called shot. Okay, and this is going to kind of control the flow. So we're going to be able to say how much force we want to hit the ball, what's the maximum force we want to hit the ball with, when does our ball stop rolling. Because if basically don't set a custom sleep speed, sometimes the ball can roll by the distance, moving a tiny amount. So we're going to just change that code. We're going to have a reference to our rigid body. We're going to create a shot force, which is based on how far we pull the ball back, multiplied by shot power, and then the max force is going to be a limit on that. And then we're going to have the start position of the mouse, which is basically going to be the ball itself, the end position of the mouse, which is going to be where the cursor is at the moment, and the direction, which is going to be an angle that line creates. And we're going to activated, then we can shoot. So if the ball isn't moving, we're going to be able to shoot, and if the shot hasn't started, we're going or sorry, once we shoot, then we're going to change side once we hit shot start. So inside the start method, we're going to have myRB equals get component, and we're going to get the rigid body component of this. Okay, and what that means is that once we start the game, we're going to say, okay, this is the rigid body attached to this game object, and we're going to set a sleep threshold. Sleep threshold equals, and this is going to be the sleep speed. So we get a reference for what the script is going to do at the start. In Unity, it's going to search through all the components on the scale object. It's going to find the rigid body, and then it's going to set a sleep speed. Going to set that to you. And I'm going to actually just going to put in a couple of values here. You know what? I'm going to put in one for everything just to make sure that nothing's happening here. So now we're going to add two more functions. So one is fixed update, which is where we're going to calculate our physics. And then the other one is going to be a private void. And we're going to create a custom, or sorry, this isn't going to be a void, it's going to be vector tree. And this is just going to calculate our mouse position in 3D space. We're going to go to this mouse position. This doesn't need to take any arguments. And we're going to start off creating this one because this is going to be used in updates for controls and then physics will be based on. So I'm going to create a vector tree. I'm going to have a position. And I'm going to say it is equal to a vector tree dot 0. And that means a vector tree with like 0 on the x, y, and z aspect. So this is like a position 0, 0, 0. Then I'm going to create a ray. So I'm going to var ray. And what array is going to do is it's going to cast a line direct from the middle of the camera to wherever the mouse is pointed. So we're going to say we're going to create an array and it goes from the camera to whatever the mouse is positioned on the screen. So to do that, the array equals camera, get access to the camera.main is our main camera in the scene. And we're going to use a built-in called screen point to array. And we're going to take the input in this position. So this. Okay. And what this means is we're not casting array yet. Well, we're creating the array. We're saying like, imagine there's a line going from the center of the camera to wherever the mouse is placed. And what that does basically is it's going to shoot away from camera to wherever the cursor. So we're going to be able to translate where our mouse is pointed on the screen to where it's pointed to in the world of the game. This can be a tricky thing to figure out sometimes, that your mouse is only working in the 2D space of the screen, and yet the world is a 3D space. So like this point here might be further away from you than this here. So we're doing a little bit of like conversion from that 2D space to 3D. And then we're going to create a raycast hit. And this is just how we're going to call this hit. And we're going to just what this is going to do, this is just going to store where the ray hits the ground so that we can save that information and access where it is. So we're going to go if, and we're going to create a raycast. And we're going to go from an array, and we're going to type in out and out. And we're going to say position equals hit that position, or sorry, hit that point. And the last thing we need to do is return. Okay, so as I said, the code in this is more complex than stuff so far. If you just practice, it's getting used to like there's no way, like Unity is so many built-in methods to do things. A lot of times it's like for your specific game, it's figuring out what way to do it and what way to do it, and you're not too difficult. But what we're doing here is we're creating a vector tree position. We're making sure it starts off at 0, 0, 0. We're creating an array that goes from the camera to wherever the mouse is in the world. We're creating a variable to store where that ray has to come off the ground. And then what we do here is this creates the ray cast. Okay? So we said what we want the ray to be. The ray cast and the physics and then actually cast a line and it tells us what. And so we've got then out of that we get the basic information for the position and we return it. So the next thing we're going to do is in the update method, we're going to create three different functions here. We're going to get three different inputs. We're going to get input, get minus down, and that's going to be minus button 0. So we're going to say if the left mouse button is down and we can shoot. So get mouse button down means get a button on the mouse. 0 just represents the left mouse button. 1 is the right mouse button, and the middle mouse button is 2. But basically what we're saying here is if the left mouse button is pressed down and the ball can shoot, then it's good. Next thing we're going to do is if, this time we're going to check the mouse button, button 0. And we're going to make sure at this stage shot started is true. So what we're checking here is if the left mouse button is held down. So get mouse button down is just the first frame. So if I click mouse button down, that's when I first click it, when you hear the click on the mouse, that's the frame where it's mouse button down. Get mouse button is true all the time as the left mouse button. Yeah. This is only true for the first time when I hold it down. This is true until I release it. And the last one I'm going to do in my desktop is we're going to use if input to not get mouse button up. And that's basically whatever frame we release the mouse button. And we're just going to make sure that's not started. Okay, so when we first, the frame we press down the left mouse button, we are going to set our start position. We're going to say that equals mouse position in the world. Okay, so our start position is wherever we're going to click the mouse button down. Okay, that's this here. Then we're going to set shot started to true, so that we know from this, so that we know we've started kind of taking the shot. And that's going to do us for that. So while we're holding the mouse button down, we're going to want to change where the end position of like our shot is being calculated from. So we are going to say end pause, and we're going to get a mouse position again. So that useful function we created down here, it's giving us lots of information. And we're going to calculate our shot force based on where we click the mouse down and where we leave the mouse up, basically. So we're going to say shot force equals math dot clamp. This clamping is where we're going to set the maximum and minimum values, basically. So what we're going to do for the shot force, we're going to get the distance between our start and end point. End plus. Okay, that's going to get the distance between those 2 points. And we're going to get counter force between 0 and force. What this basically does is say our shot force is going to be equal to the distance. So it should be like this distance value. So let's say our distance is 5 units. So then it's got to say the minimum this value should be is 0 and the maximum it should be is whatever our max force is. So if our max force is 4, it's going to say, okay, even though it's 5 units long this distance, the force is going to be 4. And that's what. That's basically what that's doing. And then when we lift up the mouse button, then we're going to apply our force. So we're going to say can shoot equals false. We're going to say shot started equals false. Because it's no longer going to be true that we've taken a shot. And then we are cool. And that is it. That's all we need there. So then inside here in the fixed update, one thing to know, and I'll actually show you this by going into preferences. Edit project settings. One thing I'm just going to show you here is if we click on time, this fixed time step is to do with our physics calculations. They're always going to happen 0.02 every 0.02. Now, we then have the time of the engine, which is our frame rate. So if there is a button here that shows take a look. I can get staff here and then see if I can play on this. So here it's showing us our frame rate. That's about that frame rate is variable, which means if we have something moving in update, it might happen around about 300 times a second. As I click play here, you might see it had dipped down a little. As this is loading and as it's updating things, we see that like the frame rate's dropping a little more calculation has to do. It goes up and down. And basically that's not a reliable calculate physics. We want our physics to be set to the fixed time step, which is done in the fixed update. But we want to get input as soon as possible. And so we normally get input in the update loop or we apply physics changes in the fixed update. So we're going to say if, and if it can't, if can shoot it's false, which is going to be the case here. We're going to say direction equals start pause minus end pause. And that means we're going to set our direction to be like by subtracting these two vectors, basically it's going to point in their direction, and that's where we're going to apply the force. And to apply the force, we go my or v add force, and the force we're going to add, we're going to type vector3 normalize, and normalizing this just means we're multiplying by 1. It's the same thing kind of we're doing the clamp up above. And we're going to normalize the direction, so we want to make sure the direction is always of like the value. And we're going to add the force in that direction. We're going to multiply that by shot force, multiply by and we're going to set force mode to like when something kind of gets hit by something. And one thing we're going to do is if my or B is sleeping, we're going to set time sheet to true. So what this is doing, it's getting the direction we want to point in, basically. And then what it's going to do is set the force. So it's going to add a force in that direction, multiplied by your shaft force and your shaft power. So we can put it continually. Then turn off the stats for now. Okay. Cool. And I was add a force there to the ball. Yeah, force on adding it probably too much, so we can play with some of the stuff. So let's set the shaft power. You can see the ball basically keeps rolling. One of the things I'm going to do is change the drag value on that. And let's say we set this to 10. So there's a lot of like playing around with variables here. So that's affecting how it's falling through the air as well. So 10 is obviously too much. So set that to 3 maybe. Set our shot power to. Another thing we can do as well is take the physics of dynamic friction is 1, just like when the ball is moving. Still probably giving it a little too much. I'm going to apply this for its friction programming as well. See. So one thing you might want to do is reduce the mass a little. And I'm going to change the shot like that. So I'm going to change the bends instead. This is, with this project, there is so much like tweaking and playing with these variables. One thing I might do is just set, so if you see here, I'm going to create a variable and I might just call it and force. Force. That's cool. And just to see if we only apply this once, I think it might work that. So we'll see. Right now, physics just it's does require a lot of playing around with things, basically. This one's a bit more like it. So now if we set the shot parameter to 5. Oh, nice. That's starting to feel kind of like cool. I'm pretty happy with that. You'll notice without UI elements to show me where I'm like what direction I'm firing the ball off in, I really struggle to like hit off the flagpole. So we're gonna need a couple UI. I'm pretty happy with how it feels. Hopefully it's something feels that too. I've probably got my like drive and stuff. Um, again, these are all things you can play with and get the feeling just the way you want. I'm pretty happy with that as like a way for this game to feel. So the next thing we're going to want to do is create the visuals for this. And to do that, I'm going to right click on the ball, I'm going to click effects, and I'm going to click line. Okay. And this is going to create what's called a line render. Zoom in on this. The line renderer basically is like just kind of drawing out a line. And this has two positions. It has a start position and an end position. And you can change the color and the alpha on these. So I'm going to click here the alpha at the end position and change its value to 0 so that this kind of fades and gradient. Maybe we go an orangey color for this. And we can do the same here. And we can deselect this add key. And that will basically taper down this, the way this line actually down. Because it's only down between 2 points, it's just going to be a straight line. I think that's all we really need to change there. But we've now got a cool little kind of line render. Just, I might want it to go completely to 0 here, but just mostly to 0. So, and selecting the ball, I'm going to create a new variable here, and it's going to be a public. And it's going to be type line render. And we call this line hour. Which is back to the ball now. Just looking for my hour. Right. Sure it was why. I feel like maybe I created the prefabs in the other scene, which is going to be a little bit of too much hassle. But just check to see that. So that is that setup, my line render. So what we're going to do is, when after a shot is started, I'm going to say my LR dot game object. So that we're going to make that visible because we're going to start the game. I'll do that now. Turn that off. And so that should oh sorry, actually, I'm going to do that one. So this game object starts off inactive and then by changing that pixel. So we're then going to say my LR, let's set position. We're going to set position 0, which is the start. And we're going to set that to the wherever the line render starts. So like the center of the ball, basically ILR, transform that local position. And that's going to be the center of the ball because it's local position of its relative to the ball. Then here, we're going to say my power add position, sorry, set position. This is going to be position 1. And we're going to set this to we're going to transform the inverse transform point. This is, I don't really know maths of this, is a bit beyond me, but what it's doing basically is it's taking the world position of the end pose and it's converting it to a relative local position for this object, basically. And the last thing we're going to do here, after we take the shot, we're going to say my power dot game object set output is false. And then we should be able to press play. We should have our line renders. Hopefully, this all looks and plays nice. Okay. So I get this little thing basically pointing at the ball. It starts to show me what direction I'm shooting in. Right. So I might want to increase my max force a bit there. Cool. Now I'm on level 2. Cool. Yeah, so I did. They did the thing I was worried about. So what I'm going to do here is I'm actually going to delete this prefab for the ball. So I'm checking if that was a prefab. Sorry, I deleted the material for the ball. Prefab. So this is like base. Just gonna hit delete on this. So then I'm going to create a prefab for the flagpole from this thing because I've done some code inside here. Yeah, I made a little mistake not doing this in this thing basically. So now if I go to draft 2, save on that. So this is missing the prefab for the ball. Delete ball, delete flagpole, delete game manager, and it just has to right that in there. So, so this time I'm actually going to drop the ball from. I'm going to have the ball drop on the bottom left hand corner so that I can see it. And the one thing I need to do is in this scene, it's at least gravity set through. This just needs to go down this way. So I'm going to go -5, 0, 0. Position. That should be okay. And then I'm going to do cycle. I'm pretty much going to do the opposite. So this should be -5. Yeah. And the cycle, I need to update the number on that. 2. So yeah, there's the ball. So make sure is linked up. Cycle, I need to make sure so I need to have game manager there. The level manager, and this is going to load my scene. The manager is going to need a reference to the end screen. And the end screen is, yeah, it's in the game, it's going to through. And lastly, this end screen button needs a reference back to the game manager, level manager script, and reload. So I think that should be everything. I'm going to save this. I'm going to go to scene one. And we're going to see, I'm going to play focus, I'm going to play maximized, and we're going to see if we can run the one thing I might do on the ball is chopper and might make 4. Or max 4, so we got this nice effect of the ball bouncing in. It's off the post, load into level 2. Cool. And then it's going to play again. Playing, it's going to be cool. The last thing we want to do there is save this and go to our build settings, WebGL. I'm going to click clear settings for WebGL and just check this compression format. I'm going to set to disabled. And I'm going to hit switch platform. This will take a minute to reload Unity. At this stage, I can build the game out and get it up on itch.io. So I know that covers like an awful lot of ground. The videos hopefully will be helpful, and then as well, I'll upload the project and you can go play the game on itch.io as well. When you're creating your levels, what I'd like you to use is to use Pro Builder to build out some custom kind of mini golf courses. So mini golf courses. There's got to be some like crazy designs here. They don't have to be anywhere near this elaborate. Simple things, maybe like you've got a slope, a target, maybe like this is probably a good example of the kind of thing. Just dropping down the slope, going around the corner, bouncing it off the walls. Does that make sense?
Yes.
I'll stop sharing my screen. So if there's no other questions, we're going to leave it there for this week, and we'll have, I might like schedule, because we got confused with whether we're in class or not. We might have like an hour tomorrow and an hour on Thursday for tutorials for anyone who needs help or support with kind of the stage there on the project. Does that sound okay?
We have classes from 1 to 5 p.m. tomorrow. So we don't have any discussion tomorrow, right? For
Switch to things so we can hear you properly, sir.
we have classes tomorrow 1 p.m. to 5 p.m.
Yeah, perfect. I think anyway, it'll probably be earlier in the day. So
Okay.
if any of you want that, like it's not essential. If you prefer, I can just be available 2 hours on Thursday.
Okay.
Is that more useful for you?
Yeah, and you also mentioned that that you're taking a session on Thursday as well. 3 to 4, I guess, in the mail.
Yeah. So what we could do there is do. Oh, do you have class at that time? Actually, sorry.
Yeah,
oh,
we do. We have class till 5, 1 to
perfect.
5.
Yeah. So what I'll do is I'll maybe say like what I'll do is if any of you want to meet on Thursday, I could meet between 10 to 12 on Thursday morning.
That would be perfect.
Yeah. So what I'll do is I'll send out an email and ask you just to email if you want a tutorial, and we'll book in. I'll set up a Teams meeting then, kind of one-on-one with anyone who wants a tutorial. Does that make sense?
Yeah.
Yeah.
Cool. I think that just should make things a little bit